And I'll finish that really quick with you. Probably be easiest if I go here. Now this situation is slightly different. The car goes up the ramp in the positive direction. So that means our slopes need to get less steep as the car slows down. Something like that. It's the mirror image of the graph we just got. Okay? And as the car speeds up in the negative direction while moving back down the ramp, remember this is the negative direction, the car goes back down the ramp, we need negative slopes that get steeper. Now our velocity is 0 at that moment, so I'm going to put a little x there. The initial velocity is positive and steep, so I'm putting an x there. Our final velocity is negative and steep, so I'm going to put an x down here and just make a line. In this class, you'll notice our position time graphs are curved when we have constant acceleration. Our velocity graphs are aligned when we have constant acceleration. And our acceleration graphs are just a horizontal line either above or below the t-axis. Since this slope is negative, we have a negative acceleration. But our acceleration is constant. So these slopes get less steep on this side, and these are positive slopes, and that's because since cart slows while moving in the positive direction, okay, on this side of the graph, slopes which happen to be negative get less, no, these slopes are getting more steep. Because on the way down, the cart speeds up. And the cart speeds up while moving in the negative direction. All right, and this is a constant negative slope. Since acceleration is constant and negative. Okay. And finally, this is 0 slope since acceleration is constant. Acceleration is constant. In other words, it's not changing. We need an equation for this graph, okay? So I'm going to make up numbers. Let's say that's 20. And let's say, no, I'm going to make it bigger than 20. Let's make it 100, all right? So let's make it the same number as we had before. So using the same numbers, but now the direction is switched. Instantaneous velocity move this over. Cool. Is equal to, that's a negative slope, so negative 20 centimeters per second per 1 second times time. Okay, and our initial velocity looks like it'd be about 100 plus 100 centimeters per second. Okay, almost done here. And last, most important step is to make sense of this slope and intercept. So every second, it looks like the velocity is changing by how much? Well, each second, the velocity each second is changing by negative 20 centimeters per second. Okay? So this is the numerator of our fraction. Okay? Every second. And then the change in velocity each second looks like it's negative 20 centimeters per second. So this part is the denominator of our fraction. This part describes the numerator of our fraction. And last, this number on the end, the y-intercept, if you were to plug in 0 seconds for time, this entire portion of the equation disappears because if time's 0, 0 times 20 is 0. 0 times negative 20 is 0. So when time is 0 seconds, your instantaneous velocity is 100 centimeters per second. So this is the velocity of cart at 0 seconds. And that's the best I could do to try to help you with number 5. And I hope it helps. Number 6, I'm going to say the position time graph is the only thing that changes, and it changes not in shape, but in one other simple way. So the graph is going to shift due to where the 0 position is, and hopefully you can figure that out if you understand. If not, feel free to come visit me, and have a good day.